I'm going to go through the Chapter 9 test with you. We're going to look at number 1 on the no graphing calculator part. And number 1 says, the variables x and y vary inversely. Whenever you see inversely, it means to divide. So it means y equals k divided by x. Then I'm going to sub in my values. X is a -2 when y is a 2. So 2 equals k divided by -2. To solve that for k, I would multiply both sides by a -2. That gives me -4 equals k. I must always remember to take that k value and sub it into my original equation. And that is my equation of variation for a. Y equals k is a -4 divided by x. Then I use that equation for b. Y equals -4 divided by x. Find y when x is 4. So I'm going to substitute in a 4 for x. And that gives me -1. So y is a -1. Number 2. Z varies jointly with x and y. Varies is my verb, so that's equals k. In front of it is z. So z equals k. Jointly means times. Times x and y is also times. Now I'm going to sub my values in. X is 2, y is 4, and z is -2. That's -2 equals k times 8. I'm going to have to divide by 8, and I get -1/4 equals k. Again, I take that k value and sub it into the first equation. So z equals -1/4 times x times y. So I had to make sure to put those in the numerator. Then to do b, I use that equation. Z equals -1/4 times x times y. Find z when x is -1, so I'm going to substitute in a -1, and y is a 4. Here I see these 4's would reduce, so I get z equals 1. Number 3, state the vertical and horizontal asymptotes in the domain and range. The vertical asymptote is this one that goes up and down, and it is always an x equals line. So it is x equals -3, because every x value is -3. The horizontal is the one that goes across. So it's going across y equals -2. So my domain, x can't be a -3. And my range, y can't be a -2, because I can never get to those asymptotes. Number 4, write a rational function with the following characteristics. Vertical asymptote of x equals 4. So this has to go in the denominator. So y equals, you can put any number you want. I'm going to put a 1. And to take it from x equals 4 back to the factor, I would have to subtract 4 from both. So I get x minus 4 equals 0. So it is 1 divided by an x minus 4. Then I can put my horizontal asymptote of -2 out here in the k spot, hk. Or I could write it in a non-parent function. Y equals, it's still going to be a denominator of x minus 4. To get y to be a -2, I would need a negative 2x in the numerator so that my y equals negative 2 over 1. Either one of these equations is correct. Number 5, graph the functions and their asymptotes. So it looks like x minus 1 is in the denominator. So this is going to shift. H is 1, right 1. K is negative 2, down 2. So I'm going to take my origin and move right 1, down 2. I'm going to make my new origin. Since I shifted my origin, it is the asymptotes. So I will create those asymptotes. Now, I shifted my origin to this spot so I can cross it out here. So I'm left with y equals 3 divided by x. So I'm going to put in 1 and 2, negative 1 and negative 2. 3 divided by 1 is 3. 2 divided by 1 is 3 halves. 3 divided by negative 1 is negative 3. 3 divided by negative 2 is negative 3 halves. So I plot from my new origin 1, 3, 2, 1.5. Hug my asymptote, curve, and hug. And then I'm going to reflect it. Negative 1, negative 3, negative 2, negative 1.5. Hug, curve, hug. Okay, number 6 is not a parent function. So I am going to have to calculate my asymptotes. My vertical asymptote comes from this denominator, x minus 1 equals 0. Add 1, x equals 1 is my vertical asymptote. So I'm going to plot x equals 1. My horizontal asymptote comes from right here. Y equals 2 over 1. That's y equals 2. This is not a parent function, so I must plot it as I was given from my origin. I'm going to pick points close to 1. So I'm going to pick 0 and negative 1, and I'm going to pick 2 and 3. When I put 0 in this numerator, I get 1. When I put it in the denominator, I get negative 1. 1 divided negative 1 is negative 1. So I'm going to plot 0, negative 1 from my original origin. Then when I put negative 1 in the numerator, I get negative 2 plus 1 is negative 1. And in the denominator, I get negative 2. Negative 1 divided negative 2 is 1/2. Negative 1, 1/2. Hug, curve, hug. Then when I put 2 in my numerator, I get 5. And in my denominator, I get 1. 5 divided 1 is 5. 2, 5. When I put 3 in my numerator, I get 7. When I put 3 in my denominator, I get 2. 7 divided 2 is 3.5. 3, 1, 2, 3.5. Hug, curve, hug. Okay, now we'll go to the calculator part. Number 7. When we are multiplying, everything needs to be factored. So I'm going to factor the first one. X times x gives me x squared. The only factors of 2 are 1 and 2. I need to add them to get 3. X squared minus 9 is also in the numerator, so I'm going to do x times x and 3 times 3. It's a difference, so I need a plus and a minus. In the denominator, I have an x minus 3, and I have an x plus 1. Now I'm going to cross out any factors from the numerator to the denominator. I see x plus 1. There is no x plus 2. There is no x plus 3. There is an x minus 3. So I get x plus 2 times x plus 3. In the next one, I am dividing and multiplying. So all my divides I have to multiply by the reciprocal. So I keep this first one, change divide to times, and then flip the one behind it. Then it still reads a times, so I don't need to do anything different. I just keep that one. Okay, I'm going to organize all my numbers. I have a 5, I have a 25, I have a 16. Just going to cross them out when I used them. I have a 4, I have a 16, and I have a 25. Then I'm going to put my u's. I have a u cubed and a u cubed. And on the bottom, a u. Then I'm going to put my s's. I have a s. On the bottom, I have a s and an s squared. All right. I'm going to reduce from numerator to denominator. 5 and 25 reduce. 25 and 5 reduce. 16 and 16 reduce. I see a 5 and a 4. Those do not reduce. So I have a 5 in the numerator and a 4 in the denominator. Here I see 6 u's. 6 u's in the numerator, 1 in the denominator. Have more u's in the numerator, 5 more. On the denominator, s cubed when I combine those. I have an s in the numerator and an s cubed in the denominator, more in the denominator, 2 more. So it is 5u to the 5th, 4s squared. Number 9 is a plus. Whenever we have a plus, we want an LCD. So my LCD, I used x's and I used y's. The largest amount of x's is x squared. The largest amount of y's is y squared. So my LCD is x squared, y squared. Whenever I add and subtract, I want my LCD to be my denominator. So in this first one, it reads x squared y. I want it to read x squared y squared, so I must multiply the denominator by y. What I do to the denominator, I do to the numerator. So y times 1 gives me a y in the numerator. Then I have my plus sign. This denominator reads xy squared, so I need to multiply it by an x, so I get x squared y squared. What I do to the denominator, I do to the numerator. So that gives me x. This numerator cannot combine, cannot factor, so I am done. This next one is a subtraction. Subtraction is adding, so I'm going to change this to add the opposite, and I'm going to put that negative up on top. My denominators need to be in factored form to find a LCD. So this is an x times an x plus 2. So I'm going to cross that denominator out, so I'm using x times x plus 2. This one factors into x and x, 2 and 1, both have to be pluses. So I'm using this denominator, so I'm going to cross this one out. So my LCD, I see an x, I see an x plus 2. In this fraction, the difference one is x plus 1. So that is the denominator I want, x times x plus 2 times x plus 1. This first fraction needs to be multiplied by an x plus 1. What I do to the denominator, I have to do to the numerator. So now I have to distribute that 2 through. So I get 2x plus 2. Then I have a plus. This denominator is missing the x, so I have to multiply by an x. So I get a negative x. Now, in this numerator, I have these like terms to put together. So 2x minus x is x. Then I have plus 2 over x times x plus 2 times x plus 1. There is an x plus 2 in the numerator and denominator, so those reduce. So I am left with 1 in the numerator and x times x plus 1 in the denominator. So when you add, you want to have an LCD as your denominator, rewrite every fraction with that denominator, add like terms, and then reduce. All right. In number 11, it is a subtraction again. So I'm going to change that to add the opposite. I put my negative up by the parenthesis, or up by the numerator. Again, my denominators are already the same. So I have 4x plus 20 as my LCD. So it is an x squared plus 20 minus x. The denominator factors into 4 times x plus 5. So I'm just going to use that denominator. The numerator, x squared minus x plus 20, does not factor any further because there are no factors of 20 that add up to 1. So that is my final answer. Now, in number 12, I am dividing. So when I divide, I change it to multiplication. So I keep the first equation, change the sign from divide to times, and flip the back one, x over x minus 3. When I multiply, everything must be factored. So x and x, factors of 6 that add up to 5 are 2 and 3. To get it to be negative 5, they must both be negative. Then I also have times an x. I have an x squared in the denominator and an x minus 3 in the denominator. Now I'm just going to reduce fractions. X minus 2 in the denominator? Nope. X minus 3? Yes. An x? Yes, there's 1 in the x squared. So I take that one out and put an x. So I am left with a numerator that has x minus 2 and a denominator of x. All right, the next one is a complex fraction. When we have complex fractions, we are going to find the LCD of every single denominator. So the LCD, well, this first one can be factored into x plus 5 and x minus 5. So I see x plus 5 is a factor. I see an x minus 5. In this denominator, I don't have anything different. X plus 5 in this one, not different. X minus 5, not different. So my LCD is x plus 5 times x minus 5. I'm going to take a moment and write that in every numerator. And the reason I'm doing this is so that I can eliminate denominators. Now I'm going to come back and I'm going to reduce. X plus 5's reduce, x minus 5's reduce, and I'm left with just the 4. Then I have a plus. X minus 5's reduce, so I have to distribute this positive 2 through. So I get 2x plus 10. There's my numerator. Now in my denominator, the x plus 5's reduce. When I distribute 1 through, I get x minus 5. Then I have this plus. That's what most people forgot. Then the x minus 5 reduces, so I have 1x plus 5. Now, I have like terms in both the numerator and the denominator. So let's put these terms together. I see 2x plus 14. In the denominator, x plus x is 2x. Negative 5 and positive 5 are 0. So now I can factor this numerator to 2 times x plus 7. This denominator is already factored. It reads 2 times x. So here, the 2's reduce, and I'm left with x plus 7 divided by x. All right, in the next one, we have number 14 has an equal sign. So again, when we have an equal sign, just like with complex fractions, we want to eliminate the denominators. So we need an LCD to multiply by. I see x plus 1s as one of my denominators, and I see x minus 4 as one of my denominators. So that is my LCD. So I'm going to take a moment and write that in every numerator. Now I'm going to come back and reduce. X plus 1's reduce. So I'm left with 3x minus 12. Then I have my equal. X minus 4 is reduced. So I have 2x plus 2. Okay. I'm going to do my restrictions. In this denominator, I have x plus 1. It can't ever be a 0 in the denominator. So I'm going to say cannot equal 0. So when I subtract 1, I get x cannot be a negative 1. There's my first restriction. In this denominator, I had x minus 4, and that can't be a 0. So I add 4. X cannot be 4. Now I'm going to solve my equation and see. Make sure I don't get either of those two values. I'm going to subtract the 2x and add the 12. Is x equals 14 not negative 1 and not 4? Yes, it is. So x equals 14 is my solution. Likewise, I'm going to do the same thing in this next one. So I need an LCD, but this one needs factoring. X plus 2 times x minus 2. So I'm going to cross that out. So in this denominator, I have an x plus 2. In this one, I have an x minus 2. And in the last one, I don't have anything different. So my LCD is x plus 2 times x minus 2. So I'm going to take a moment and write those in every fractions numerator. Now I'm going to come back and reduce. X plus 2 is reduced, so when I distribute that 1 through, I get x minus 2. Then I have my plus. X minus 2 is reduced, and when I distribute that, I get 2x plus 4. Then I have my equal. X plus 2 and x minus 2 reduced, so I'm left with 1. I'm going to come back and do my restrictions. Here was x plus 2. Can't be a 0. Subtract 2, subtract 2. X can't be a negative 2. Here, x minus 2 can't be a 0. So x can't be a positive 2. Now I'm going to come back here and solve my equation. X and 2x make 3x. Negative 2 and 4 make positive 2. Subtract 2. 3x equals negative 1, or excuse me, positive 1. Divide by 3. X equals 1/3. Is 1/3 not negative 2 and not 2? Yes. So x equals negative 1/3. Okay, you should now have enough notes to retake the problems you had wrong.